All right, so welcome to final exam math review. This is sheet number one, part one. I think I'm just going to be doing the first 8 pages of this, right? So this will just be pages 1 through 8. Checking things out here, so we might as well get right to it. So 3 points of a triangle are at a negative 2 comma 5, a negative 2 comma 10, and a 5 comma 10. But all they care about is the distance here between B and C. So I just care about the distance between these 2 points. So let's see. So we have an X and a Y, and it looks like the Y values are exactly the same. Now, if we remember here, if I am going to throw this on a coordinate grid, right? If I have that negative 2 comma 10, that would be a negative 2. There's my X, there's my Y. 1, 2, 3, 4, 5, 6, 7, 8, 10. He's over here somewhere. And the other one is at a 3 comma 10. 1, 2, 3. He's out here somewhere. We're looking for that distance. Now we can count things out and say, hey, if that's a negative 2 here, that's 1, 2, 3, 4, 5 away, right? 5 units away. Or we can look at absolute value, right? So distance from 0, the absolute value of a negative 2, right? Added 2 because they are opposite signs, right? The absolute value of 3. So since they are opposite sides, signs, that means they're on opposite sides of an axis, we add the values. Okay, if they were the same sign, we would subtract. So this becomes 2 plus 3 equals 5. So I just proved this 2 different ways. I drew it out, and I also proved it using absolute value. There you go, choice B. Next, the box contains 200 grams of cereal. Okay, box B contains some unknown amount of cereal, but there's a ratio box A to box B. So what I like to do now, I hear ratio, go right into ratio chart land. So I have box A, I have box B, and I have a 1 to 5 ratio. So there's a 1 here, there's a 5 there. And so box A contains 200. Now be careful where you put the 200. It's with box A. So he goes right over there. Okay. And I'm looking for this value. Well, I noticed that to get from 1 to 200, I can multiply by 200. So it looks like I'm going to do exactly the same thing. So 200 times 5 is 1,000. There you go. Choice C. Okay. Next. Oh, a net. Well, a net is taking a 3D figure or 3D solid, right, and flattening it. So it looks like this. You just unravel the thing, kind of like a box. You unravel a box, maybe from Amazon or something like that. Well, this particular one has 2 bases that are triangles, okay? And if they fold up, and then these rectangles become the faces or the sides, right? So it has 1, 2, 3, 4, 5 faces. It wraps up, they have a triangle on either side, and turns into like a tube, which is known as a prism, right? Prism. If it all came to a point somewhere, then you would have a pyramid, right? Kind of like something like that. You would have a pyramid, comes to a point, but we have a prism, kind of like that. That's what this guy is. You can see there are the triangles, and then I have the faces, the 3 faces. That's what it makes. So prisms are named after their bases, right? What I like to call the slice of bread. So if this was a loaf of bread and you wanted to make a sandwich, you'd cut slices. Well, the slices are made out of triangles, so it becomes a triangular prism. Okay? If you try to make a sandwich out of this thing, the slices would not be the same size. You'd have big guys on the bottom, little guys on the top. No good. That's a pyramid, right? That's a pyramid. This is a prism, so choice A. All right, so that takes care of that guy. Let's keep on going. Question number 4. Following shape is plotted on the coordinate grid. What is the total perimeter? Well, the perimeter is the distance all the way around. So what I would do is simply just start counting and labeling. So that's a 2. Don't forget that guy. He's a 1. 1, 2, 3. There's a 3. There's a 2. There's a 2. There's a 2. 1, 2, 3. 1, 2, 3, 4, 5. They are all my sides. So I just add them up. So I have a 5 plus a 2 plus a 1 plus a 3, plus another 2, plus another 2, plus another 2, plus a 3. There we go. So 7, 8, let me put those together. 8 plus, let's see, 3, 4, 5, 6, 7, plus a 7, they're gone, plus a 2 and a 3, which is a 5. So I'm just boiling this thing down here. There's a 15 plus another 5. That gives me 20. Now what I want to do is actually just freelance count and cross off as I go. Now watch, just to double check. So I've 2 3s, that's a 6, that's 8, 10, 12, 14, 15, and then that 5 gives me 20. So I just did that twice, so I'm pretty certain that's the answer. Okay, well, that takes care of that guy. Next, there are approximately 250 students in Esquake Middle School based on the number of the chart below. How many kids like plain pizza? So I'm just going to circle this area here. Oh, percentage. A percentage is some value out of 100. So I'm just going to write 40 out of 100. Okay, and I'm going to go into ratio chart land. Other ways to do this, but this is the way I kind of like. So I have a plain and a total. Okay, and I have 40%, which is 40 out of 100. I can boil that down a little bit if I want. Maybe make that a 20 out of 50. I can make that a 10 out of 25, right? I can keep going, right? I can divide both of these guys by 5. Let's see, I can make a 2 out of 5. There you go. All right, well, what's up? We have 250 total students. Well, if I have 250 total, there it is. That goes on this side right there. Oh, look, I'm going to use this guy. Aha! There's a 25 times 10 gives me 250. So I'm going to multiply by 10 over here. And that gives me 100. So 100 students. There you have it. Now the other way would just to do the part over whole, right? Part over whole like that. Remember that? 40% is 40 out of 100 equals some value, right? The part over the 250, and that's the whole, right? And then what I can do here is I can simplify, right? And if I simplify, maybe I get that 10 over 25 like I did before, equals some number over 250. And there you have it, right? Times 10, lots of ways to do this one. Times 10 that way, and there's my 100, okay? So lots of ways. All right, let's see. Let's go to page 6. Rich began a new running routine, which he runs 10 miles every 4 days, right? And Bill, he has a running routine and he runs every 5 days. So if they both start training on the same day, what day will they both train on the same day again, right? So that looks like a LCM problem, a least common multiple problem, right? So let's see, we have one guy is Rich and we have B for Bob, right? So the next day, so he runs every 4 days, he runs every 5 days. So if I just keep on going here, 12, right, 16, 20, right, and so on, right, 24, this guy is 10, 15, oop, there's my 20. So they'll hang out again on the 20th day. There you go, LCM, least common multiple, okay? Convert this guy to a decimal. Oh, we already know, right, some value over 100. And all I have to do is read it, 6/100ths, right, 6/100ths. What does that look like? Don't forget that 0 right there, because this is the hundredths place. Tricky problem. So many people want to do this guy. Nope, that's not it. 6/100ths. A. Okay. Let's see, which statement about the prism on the right is true? Well, vertices and faces. Oh, okay, faces. Well, the faces are the flat parts, right? That's a face. Vertices are the corners, right? That's vertices. Okay. Edges are where the faces meet. That's an edge. Okay. So, what's up with this guy? Let's see. I guess we have to count everything up. So faces. 1, 2, 3, 4 around, and then 1 on either side, right? So that's 6 faces. Edges, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it looks like 12. Equals 12. And the vertices, the corners, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's see what's up. Let's see. The number of vertices in the faces are equal. No, nothing's equal there. Edges to faces is 2 to 1. Edges to faces. Well, edges are 12, and the faces are 6. So yes, that's a 2 to 1 ratio. Right? It's double the size. There are exactly 6 vertices. That's not true. We have 8. All the faces are congruent. That means they have the same size. Same size. They're equal. Is that true? All the faces? No. Some of them are much thinner than others. So no, that's out. Choice B. Okay. Next, Angelo. He ran 55 minutes on Monday at a 5-to-1 ratio. Minutes to kilometers. Okay, so let me say minutes to kilometers, right? Minutes to kilometers. 5-to-1 ratio. All right. How many kilometers did he actually run? Well, he ran 55 minutes, so 55 minutes. There it goes on the left side. So that looks like a times or multiplied by 11 times 11. So 11 kilometers. There you have it. Okay. So that takes care of that page. Let's keep going. We're doing great. So now we're on page 4. Which solution would make this true? Oh, I love these. So this is an algebra deal, right? So I want to run an inverse operation. This is division, so I want to multiply by 17 to get rid of that 17, which means I'm going to multiply by on the other side as well. So now I have a 17 times a 5. So that's a 35. That's a 5, 6, 7, 8. Okay, so 85. There we go. Now, if you want to check that, just rewrite it. So I have an 85 and my 17, and there you go, right? Because 85 divided by 17 is 5. 85 there, done, and we are checked out. Cool. All right, so next one, Alexandra, she plotted the first 3 corners of a square. Oh, okay, so it's a square. So we want the other corner right here, right? What are the coordinates of the 4th corner? Well, let's see. Ordered pair, so always x before y. So my x is my -2. There it is right there. And my y is my 6. There it is. So -2, 6. Choice D. All right. 12, we have a rectangular prism. So let me just draw one. All right, so I put 2 squares inside one another like that, and I do that. It's kind of fun. So I have length, and I have a width, and I have a height, right? 3 dimensions. One's 11 inches, and 16 inches, and a 22 inches. Doesn't really matter which one's which. Okay. I want to find the volume. Well, the volume is the length times the width times the height. So I want to multiply all these guys. Okay. And that's choice B. That's what I want. Okay. So that takes care of that guy. All right. So let's continue here with problem number 13. Right now, this guy here, they want which fraction below is the greatest, I suppose, has the greatest value. Now, I see that they all have 8 as a whole number. That's good news. So it's really about the fractions. I have a 1/2, I have a 3/9, I have a 3/4, I have a 16/20. One approach is to actually find a common denominator for all these guys and then locate a numerator. For example, if I have a 20 here, I have a 20 here. There's only one problem though. I can't make a 9. I can make a 4 into a 20, right? Multiply everything here top and bottom by 5, but that's not going to work for this guy. So if you run into that issue, which clearly this is an issue, you're just going to have to fall back on my wonderful old phrase of when in doubt, divide. Okay, in other words, turn it all into a decimal. So this is going to be 8 point something, 8 point something, 8 point something, 8 point something. Now, some of them are more obvious than others. 1/2 is really 0.5. If you don't know, just divide, right? Put your decimal up there, right? Put a 0 in there. That goes for 10. There it is, 0.5. So there's a 0.5. This guy, 3/9, knock it over, right? So if I have a 3/9, that is equal to 1/3, right? Simplify. Divide each by 3. And then knock it over. Put your 1 in the box. Add a couple of zeros. Get your decimal up there, right? And start dividing. 3 goes into 1 0 times, but it goes into 10 3 times for 9. I get 1 left. Oopsie. I didn't want to put that 0 there. I wanted to put an arrow. Put an arrow down, right? Drop that down, another 3. In fact, this is going to go on forever. So this is 0.3 repeated, okay? And the next one, 3/4. Again, I'm just taking a look at these fractions, right? 3/4, right? Drop it off. 3 goes in the box, bring it on up, add the 0, okay? That's 0 times, that's a 7 for 28. For 2, add another 0, bring it down. That goes 5 times for exactly 20, and we're done there. So that's 8.75. And then I have a 16 over the 20. Now I'm just going to start simplifying that. Divide that in half. Right, divide each in half. I get a 4/5. Actually, 8/10 I should have stopped right there because it's 8/10. There it is, right? 8/10, 8/10. And so there it is. So I'm looking for the one with the greatest value, and clearly this guy is the greatest value because if I matched up all those um, place values, this would be a 3, this would be a 0. So I have a 50, a 33, or about 33, a 75, and an 80. So the 80 wins. There you go. So that one's the greatest value. Okay. So notice everything is proven, folks, and that's what I want to do here. So which point is the reflection of the point over an x-axis? Well, I'm going to draw that one. So here's my x, here's my y-axis, and I'm going to put this guy at a -3. 1, 2, -3, right? 1, 2, 3, 4, 5. There it is. There's the point, and it's reflecting over the x-axis. Here's the x. So he's going to jump over. He's going to land over here somewhere. Well, the question is which value actually changes? The x value is still that -3. That doesn't change. It's the y value that actually changes. It was a +5, and now it's a -5. Okay, so that is choice A. Okay, but notice again, I am drawing this out. I want to get these right. I don't want to mess around. There's a shirt on sale for $15. The sale price is $5 less than the regular price, which is P. Huh. Okay. So what's going on? Well, if it's on sale for $5, you're removing $5, right? What equation could be used to find the price of the shirt? So P is the original price. We're going to remove $5, right? And it says it's on sale for 15, so that's the price you're actually going to pay. So there it is. Choice, oopsie, I almost circled two things. Choice B, okay? Next, in order for airports to be shut down, wind gusts W, so that's the wind gust is W, has to be at least 40 miles per hour or greater. Okay, so at least 40 miles per hour or greater. Which inequality shows that? Well, or greater at least, so it could actually be 40 degrees, right? So these guys, that guy's out. This means it has to be 40 degrees and 40 degrees only. That doesn't make any sense because if it's 40 degrees, you shut down the airport. But if it's 41 degrees, you reopen it. That's silly. But it's not this one because it actually could be 40 degrees and they shut down the airport. Okay. This one is no good because they're shutting down the airport with winds that are less than 40 degrees. So anything over 40 degrees, then they reopen the airport. Makes no sense. So this is it. So any wind that is greater, right? That's a terrible arrow. Greater than or equal to 40, they're shutting down that airport. So that's choice C. Okay. Next, number 17. In order to solve for n, let's see. Solve for n, which operation, would have to be done to both sides of the equation? Well, this is currently, the 5 is being multiplied by n, so I'm going to have to divide both sides by 5 in order to make this successful. And they don't even want you to do it. They just want to quizzing to make sure you know what actually has to be done. Okay, so Mrs. Lovecchio buys cold cut roast beef, yummy, at a rate of $7.80 per pound. Well, what does it actually cost if she purchases 1.5 pounds? Now you can do a straight multiplication on that, or you can say, hey, right, ratio chart land. Here we go. So per pound, right? So we're talking about $7.80 for 1 pound, right? 1 pound, right? And then dollars, right? And if she buys 1.5 pounds, then how much is that? So that's a multiply, right? So times 1.5 times 1.5. It shows you to do that. So where do I work that? Let's see, I need some space. So how about a 7.8 up there times a 1.5 over here? Okay, so that's a 40, 35, 39, right? There's an 8, there's a 7. Bring it on down, right? So 17, 10, 11, 2 digits after the decimal in my question, right? So that's looking like $11.70. There you go. Okay, good stuff. Number 19, which inequality is this modeling? Ooh, this is an interesting one. So I like to put the x right smack in the middle, x in the middle, and I have a 5 on this side, and I have a -3 on this side. Now, it's all about, let's see, and the x is going to be less than 5, but notice that's an empty circle, so we leave that. That's good. But this guy is filled. So x is going to be greater than that -3 and or equal to it, right? So it's a filled up circle or equal to. So I need that guy right there. So this guy's here. Now remember, I always read inequality starting with the variable. So from the x, I say x is less than 5, and then x is greater than -3. So you're always starting in the middle for these types of things. You read starting in the middle with the variable. Okay, and so that's that guy. Oh, and I didn't choose a, make sure you're choosing carefully that it matches up the right way. It's this one. Okay, that's the perfect one. The others are, they all look very similar, but there's only one that matches up. Okay, next. 3/4 pound of bird feed can be made from, from 5.5 pound of bird seed. Let's see. So how many? So I want 3/4 of, right? So I want 3/4 of 3/4 pound made from 5.5. Let's see. So if I have 5.5 there. Okay, yeah. So this one is, if you're starting with 5.5, you're asking, hey, how many 3/4 are actually in this, right? So how many 3/4 pounds are in 4.5? So that's a division problem, right? So how many 3/4 are actually in that? So this is a keep, change, flip situation here. So first I'm going to take this guy, right, and turn him into an improper fraction, 10. So I have 11/2. That's my keep, then my change, and then my flip. So 4/3, like that. So I want the 43/6, like that. Or I can simplify before I multiply. I get a 1 there and a 2, and I wind up with a 22/3. And now I can knock that down, right? So that goes 7 times for 21 with 1 left, 1/3. So 7 1/3 pounds. There you go. Okay, so that's the answer to that guy. And let's keep on going, right? So the length of Mr. Henderson's driveway is 5 feet longer than twice the width. Okay, so let's see, 5 feet longer than twice the width. Let W represent the width of the driveway. Okay, so let's see. So W equals the width, right? So the width, right? And oh, actually, I can tape diagram this thing. Let's see. So we have the W, the width, and the length, right? And it's 5 feet longer than twice the width, right? 5 feet longer than twice the width. 5 feet longer than twice the width. So the width, if the width is this guy, right, it's 5 feet longer than twice the width. So I need twice plus a 5, kind of like that, right? So which one is that? So that's got to be this one right here. So twice the width plus 5, right? Because this is W, W, W. And so the length, right? Which expression shows the length? I have 2 W's plus a 5. So 2W plus 5. There you go. Okay. Which one demonstrates the distributive property? Well, the distributive property is probably going to be this one, right? 8 times 7, right? There's my 8 times 7 plus, there's my plus, my 8 times 5. There it is, 8 times 5. So it's being distributed, right? So let's do that again so you can see what's up, right? So I distribute, meaning 8 times 7. You know me, I like to use parentheses. And then I distribute the 8 to the 5, like that, okay? And that's this guy. Okay, the others aren't doing this. This guy here is an identity property, right? Identity property of multiplication, right? This guy, 22, 8, 15, 22, 8, 15, they're just changing the grouping. This is called associative property. Associative property. And this guy, since they're changing the order, is commutative. Commutative property. Okay. All right. Oh, we need to evaluate. Oh, I love these. Okay, so we have a 55 minus a 2 times. All right, actually, I don't need that there. A 12 minus 5, and then a plus 2 to the 3rd power. So we always take care of parentheses first, right? So that gives me a 7, right? I'm going to use that dot for the 2. Times 2, I'm bringing everything down, right? One thing at a time. There you go. And now for the exponent. So this is 2 times 2 times 2. So it's a 4 times 2, which is 8. right? So there's an 8, there's a plus, there's a 7, there's a times, there's a 2. Everything comes down in the same order. Now I need to multiply. There's a 14, add that 8, oops, that's a 14. There's that 55, and now I have to subtract, right? So that is what? 41 plus the 8, right? Add that now, and that's a 49, and that's choice C. Okay? We're doing all right here. Oh, that shouldn't be there. That should be up in there. That's pretty funny. Anyway, uh-oh, did that mess up everything? Oh, look at the formatting. Oh no. Anyway, so which other fractions will result in a repeating decimal? Actually, this guy here, right? So if he's 2 over 10, that's just 0.2, right? This guy here is he winds up being 1 out of a quarter, which if you divide, you get a 0.25. This guy is 0.5. We did that earlier. This guy, I think we did this one earlier, right? So 3, 1. Watch what happens here. This is the repeater. He goes 3. You get a 9. You subtract, bring down. You get a 3 again. Yep, this guy goes on forever. It's that guy. Okay. Let's see. GCF of 12 and 48. GCF, greatest common factor. Okay, well, you can list all the factors, or you can have some fun with factor trees, right? So let's see. Remember this fun stuff? Prime factorization. Let's see. A 2 times a 6. Circle the 2. He's prime. And how about another 2 times 3? They're all prime. You circle all those guys. Then you go to the 48. And how about a 6 times 8? Gives me 48. Nothing prime, so don't circle them. Remember this? Then a 2 times 3 gives me 6. They're prime, so you circle those. And then I have a 2 times 4. Circle him. Don't circle him. He's not prime. And he becomes 2 times 2. They're all prime, so you circle those, right? So GCF, just list the ones that they have in common. Here's a 2. There's a 2. Put down a 2. There's another 2. There's another 2 times 2. And then there's a 3. And then another 3 times 3. Nothing left, right? We're done, right? Because those are all used up. So 2 times 2 is 4. 4 times 3 is 12. So therefore, my GCF is 12. Here you go. Okay. We're doing pretty well. All right, next. Reciprocal of 8. Now, careful. Reciprocal, right? You have to start with this. That's the 8. The reciprocal would be 1 over 8. Now, what you're looking for is when you multiply, you get a total of 1, right? You get a product of 1. That's a reciprocal. That's what it means. So it has to be this guy here, okay? But make sure you write this. I have so many kids just automatically pick this one because they see the 8 over 1 and they just get it wrong. So be careful. Evaluate 6n minus n equals 7, y equals 5. So I'm just going to write it first, nice and neat. And then comes my n, which is 7. Then minus my y, which is 5. Then I multiply, I get 42 minus 5. So I just have to pull that off, right? 42 minus 5. There's a 3. What is that? A 7. And then 37. So 37. And there it is. Choice B is 37. Okay. Ooh, evaluate. Ooh, this isn't so bad. Let's see. 5 1/3 divided by 2 2/3. Well, I want to make all these things improper first. So multiply and add is 16 over 3 divided by, let's see, multiply 6, 7, 8/3. Okay, now I keep, right, change because I'm dividing. And then flip. Ooh, look what happens here. Those guys divide out. Oh, look what happens here. Divide these guys by 8. I get a 1 and a 2. I wind up with a 2 over 1, which is 2. That's nice. There you go. Oh, it's a terrible circle. That's this guy here. There you go. Next, last one for page 8. Here we go. Which set of numbers is ordered from greatest to least? So basically number lines, right? Number lines. Let's see, I have 4 things. 1, 2, 3, 4. Right? -8. Okay, the -1 would be there, the 1 was there, 5 would there, but they're listed from least to greatest, right? This is least, this is greatest. He's out. This guy here, the next one, 1, 2, 3, 4, -6, -10. Well, he would be over there. And then a 0? What? No, that doesn't work. Okay, the -10 would be there, the -6 would be there, then the 0. Totally out of order. This guy. Let's see about this guy. Right, so greatest to least. So 31, 2, 3, 4. He's there, perfect. Then the 17, that's working. The -4, then would come the -5, so he's good. one last one. There we go. So 1, 2, 3, 4. The negative 22, well, he's smaller than the negative 15, but he's smaller than. I want greatest to least. Well, he's already out. Okay, so it's choice C. All right, folks, so there you go. There are the first 29 problems, pages 1 through 8. Hope you enjoyed that. Take care. So long. Bye-bye.